It's amazing how even something as, fundamental as yarn is constantly being tweaked and improved.
Yeah, absolutely.
Think about those incredibly comfortable and stretchy clothes we all love. That's not magic. It's down to some really clever material science happening on a fiber level. Stretchable fabrics have become indispensable, haven't they?
They really have. Consumer demand for comfort and performance is a huge driver in the textile industry. We've moved way beyond just natural fibers. It's all about engineering these, hybrid yarns that can do specific jobs incredibly well.
Okay, let's unpack this then. Today, we're taking a deep dive into a research paper analyzing something called Siro dual core-spun yarn. Now, this isn't your standard thread.
No, definitely not.
Imagine a tiny cable made of an elastane core, that's the stretchy bit, and a PBT core polybutylene terephthalate, which is a strong and resilient synthetic,
Right.
all wrapped up in cozy cotton.
Exactly. That combination is what makes it so interesting. You get the stretch from the elastane, the durability from the PBT, and that familiar feel of cotton on the outside. The real magic, though, is in how these elements are put together.
Okay, so for you, the learner, our goal today is to understand how new ways of manufacturing this specific yarn are leading to superior quality and performance.
Right.
This is the kind of behind-the-scenes innovation that ultimately makes your clothes better, even if you don't see it directly. We're going to pull out the key insights from this research without getting, too tangled in overly technical jargon.
And the research itself, it comes from a 2025 article in the Journal of Industrial Textiles. It's titled, Analyzing the Properties of Siro Dual Core-Spun Yarns, produced with a modified roller for industrial application. So this is fresh, pretty cutting-edge work.
Definitely. To help us navigate this fascinating area, we're delighted to have our expert speaker with us. Let's maybe start with why these stretchable yarns are such a big deal in the first place.
Sure. If we kind of zoom out a bit, the popularity of stretchable fabrics really mirrors how we live today.
Yeah.
People expect their clothes to be comfortable, to move with them.
Yeah.
Whether they're hitting the gym or just, going about their day. Look at how ubiquitous stretched denim is now.
Oh, totally.
It gives you the look of classic denim, but with so much more freedom,
Yeah.
This research is looking at the fundamental engineering that makes those kinds of fabrics possible. Think about how this could revolutionize athletic wear, allowing for greater freedom of movement, durability, maybe even leading to lighter, more efficient designs.
And it's not just one superfiber doing all the work, is it? The paper mentions hybrid yarns. What are the key benefits of combining different fibers like this?
Right. Hybrid yarns are, they're all about synergy. You take different fibers, each with their own strengths, and you combine them to create something even better. You might have the inherent stretch and strength of synthetics combined with, say, the softness and breathability of natural fibers. This Siro dual core-spun yarn is a prime example of a really sophisticated hybrid approach.
Okay. Now, this paper talks about Siro yarn as being a step up from older methods. What makes it special?
Well, what's fascinating here is that Siro spinning itself was an innovation. It's a process where you spin two separate strands of fibers, they're called rovings, at the same time.
Two at once.
Yeah. And this results in a yarn that has less hairiness. Think of it like a smoother surface.
Okay, like less fuzzy.
Exactly. Less like a fuzzy sweater that might pill. It also gives you improved strength and the ability to stretch more. Its elongation is better.
Less hairiness definitely sounds like a plus.
Oh, it is. A smoother yarn not only feels better against your skin, but also makes the fabric more resistant to pilling and abrasion.
Right, so it lasts longer.
Yeah, meaning your clothes will likely last longer and look better. Siro spinning achieves this improved uniformity by combining principles of compact spinning, which tightens the fibrous structure with the production of these paired yarns.
The paper also references quite a few previous studies on Siro yarn. It sounds like the benefits of Siro spinning have been pretty well established then.
Exactly. There's a solid foundation of research behind Siro yarn. Studies going back to 2019 and continuing right up to this year have consistently shown its advantages.
In what ways?
Well, for example, research has looked at how the strength is distributed within the yarn, how different fiber blends perform with Siro spinning, the yarn's stability, how comfortable fabric's made from it are to wear, its tensile properties, it's how it behaves under tension, the surface quality of the resulting fabrics, its durability even under tough conditions.
Wow.
And direct comparisons with traditional spinning methods. Some studies even examined how it holds up to repeated stress, like fatigue. All these studies basically underscore the benefits of the Siro technique.
Okay, so Siro yarn is already a good thing. Now this research introduces a new twist, a W-grooved roller. What's the innovation here?
Right, here's where it gets really interesting. The central point of this research is this modified W-grooved roller system used in the yarn manufacturing process.
Okay.
Standard spinning machines often use V-shaped grooves to feed the core materials, the elastane and PBT, into the yarn.
Right, I can picture a V-shape.
Yeah, this W-grooved roller is a novel design. It's specifically engineered to feed those two core components alongside each other, but in a more controlled manner.
A W-groove.
Huh. So it's a subtle change to the machinery that actually creates the yarn.
Precisely. It's a different way of guiding those core filaments as they're being integrated into the yarn structure and wrapped with the outer cotton fibers. The researchers hypothesized that this new way of feeding the core would lead to even better performance in the final yarn.
Better performance how?
Particularly for industrial applications where durability and consistent quality are crucial. Okay, so how did they put this new roller to the test? What kind of experiments did they run?
They created 5 different yarn samples. All had a cotton outer layer, but they varied how the elastane and PBT cores were introduced during spinning.
5 different ways.
Yep. Let's maybe walk through these 5 methods quickly.
Sounds good. Give us the breakdown.
Okay. The first method, they labeled it R1, was the sort of standard way. Both the elastane and the PBT filaments were fed together using a typical single-grooved roller, conventional,
Okay.
the baseline.
Pretty much.
The second method, R2, also used a single-grooved roller, but with a slight variation. The PBT and elastane were first combined using a technique called hollow spindle covering before being fed in together.
Hollow spindle covering. Okay, what about the third?
For R3, again, a single-grooved roller, but this time the PBT and elastane were combined through texturing, which is also known as intermingling, before being fed. It sort of tangles them together beforehand.
Got it. So R1, R2, R3 are variations on the conventional approach.
Right. Now, the really interesting ones are R4 and R5, which used the new W-grooved roller.
Okay.
In R4, the PBT filament was fed separately, using one of the grooves on the W-shaped pulley, while the elastane was fed in the conventional way along with the cotton fibers.
So one core gets the special treatment in R4.
Exactly. And in R5, it was the other way around. The elastane filament was fed separately using the W-grooved pulley, and the PBT filament was fed conventionally alongside the 2 sets of cotton rovings.
Interesting. So separating either the PBT or the elastane using this new roller.
And it's worth noting, all 5 of these yarn types had a similar thickness, a yarn count of nil 161.
Which means?
Which makes them suitable for medium to heavyweight fabrics. Think denim, upholstery, that kind of thing.
Right, so 5 different ways to make this dual core yarn. Now for the big question, what were the results? Did this new W-grooved roller actually make a noticeable improvement?
Well, the results were quite clear, actually. The yarns produced using the modified W-grooved roller that's R4 and R5, they consistently showed better mechanical properties.
Like what?
Specifically, they could stretch more so, higher elongation, and they were stronger compared to the yarns made with the traditional feeding methods R1, R2, and R3.
Wow, okay. That's a significant improvement. Was one of the W-grooved methods particularly better than the other? R4 versus R5?
Yes, the R5 yarn, remember, that's where the elastane was fed separately, using the W-grooved pulley. That one actually showed the highest levels of both elongation and strength.
Why would separating the elastane make such a difference?
The researchers believe that feeding the elastane separately, and especially from a specific side relative to the other fibers, helps the fibers bind together more effectively in the yarn structure.
Okay.
Which reduces the chance of them shifting or slipping when the yarn is put under tension.
So just by tweaking how one of the core components is introduced, you get a yarn that's stretchier and stronger. That's pretty remarkable.
It really is.
What about the overall quality? Did it look or feel different? You mentioned hairiness before.
Absolutely. The R4 and R5 yarns also showed improvements in several yarn quality characteristics. Things like less hairiness, better evenness along the length of the yarn, and fewer imperfections overall.
Fewer flaws.
Exactly. It seems that the more precise positioning of the core materials, thanks to the W-grooved roller, leads to better control during the spinning process and fewer irregularities in the final yarn structure.
Right.
The research paper even includes some conceptual microscopic images that illustrate this reduction in hairiness in the R4 and R5 samples.
And less hairiness means?
A smoother yarn, which translates to a fabric that's less likely to pill and feels nicer.
Okay. And the actual amounts of cotton, PBT, and elastane in the yarn, were those different across the samples? Did they change the recipe?
No, interestingly, the fiber composition was remarkably consistent across all 5 yarn types. It was about 80.19% cotton, 14.17% PBT, and 5.64% elastane for all of them.
So the improvements weren't due to changing the ingredients,
Nope.
Just the way they were put together.
Exactly, just the manufacturing method.
The paper also mentions something called the Yarn Quality Index, or YQI. What's that designed to tell us?
The YQI is basically a single number that gives you an overall assessment of the yarn quality. It considers several important properties at once.
How's it calculated?
In this study, they calculated it as elongation percentage multiplied by strength, all divided by the unevenness percentage.
Okay, so higher stretch and strength are good, more unevenness is bad.
Precisely. Higher stretch and strength increase the YQI, while more unevenness decreases it. It gives you a balanced view.
That makes sense as a single metric for overall goodness. And how did the different yarns score on this YQI?
Well, not surprisingly, given their superior strength and elongation, the R4 and R5 yarns had the highest YQI values.
Ah, so the W-grooved roller methods came out on top again.
Yeah. It reinforces the idea that the W-groove roller helps produce a higher quality yarn overall, considering multiple factors.
They also delved into some serious data analysis with something called MANOVA. That sounds quite technical.
It is a statistical technique, yeah. MANOVA stands for Multivariate Analysis of Variance. But the main point for us is that this analysis confirmed that the differences they observed.
The better strength, elongation, YQI.
Exactly. Those differences in the yarn properties between the different spinning methods were statistically significant.
Meaning they weren't just random chance.
Right. Not just due to random variation. The p-values were below 0.05, which is the standard threshold for significance in research. And they noted a high F value for the YQI specifically, which indicates that the manufacturing method had a really substantial impact on this overall measure of yarn quality.
Okay, so statistically significant improvements. That's a strong endorsement for the new roller. But they didn't stop there, did they? They also used a method called MORA.
That's right, MORA.
Tell us about that.
So the MORA method, it stands for Multi-Objective Optimization by Ratio Analysis. It's essentially a decision-making tool. It's a way to rank different options when you have multiple criteria you care about.
Like comparing cars based on price, fuel efficiency, safety.
Exactly like that. In this case, the options were the 5 different yarn samples, R1 through R5. And the criteria were all those quality measures. Strength, elongation, unevenness, hairiness, the YQI score, and the number of imperfections.
Okay.
So it's a way to see which yarn comes out on top when you consider all the important factors together, not just one or two.
And how do they actually do that? How does MORA work?
Well, basically, you create a tape, a decision matrix, with the yarn samples and their measured values for each property. Then those values are mathematically adjusted or normalized so you can compare them fairly.
Well, apples to apples.
Right. Then each property can be assigned a weight based on its importance, although in this study they assumed all criteria were equally important just to keep it straightforward. Finally, an overall assessment score is calculated for each yarn based on these normalized weighted values. And then you just rank them based on those scores.
Simple enough in concept. And the top-ranked yarn was, let me guess, R5.
You got it. According to the MORA analysis, the R5 yarn, the one where the elastane was fed separately using the W-grooved pulley, came out as the best overall.
Wow.
The R4 yarn was ranked second, again highlighting the advantages of using that modified roller.
And the worst.
The R3 yarn, where the core materials were combined by texturing before spinning, performed the poorest in this comprehensive ranking.
So this W-grooved roller, particularly the R5 method, seems to be a genuine advancement in making better stretchable yarns. What are the potential implications for the textile industry? What does this mean practically?
Well, if we look at the bigger picture, these findings suggest that textile manufacturers could potentially adopt this W-grooved roller technology to produce higher quality stretchable yarns more efficiently.
Which means better fabrics for us.
Ultimately, yes. This could lead to fabrics with improved performance, better longevity, which is obviously beneficial for consumers. It's particularly relevant for things like activewear, denim that holds its shape better after washing and wearing, and durable sportswear, basically any application where a high stretch and elasticity are key.
Are there any potential drawbacks or areas that still need more research? You can't just flip a switch and use this everywhere, right?
That's a good point. The researchers themselves mention one potential issue to keep an eye on, because the PBT and elastane in the yarns made with the W-grooved roller, R4 and R5, are sort of wrapped rather than being perfectly centered. This might affect how evenly the yarn takes up dye.
Oh, right. You could get uneven coloring.
Potentially. They suggest that future research should definitely investigate dyeing processes and how well they work with this specific yarn structure. You wouldn't want patchy colors in your fancy new stretch jeans, right?
Definitely not. Good point. What other questions could future research explore?
There are several interesting avenues. One would be to test the W-grooved roller with different combinations of core fibers, maybe different types of synthetics, or even natural fibers. Another would be to see if combining this roller system with other advanced spinning techniques like compact spinning, which we mentioned earlier, could lead to even further improvements. Synergy upon synergy.
And what about the fabric itself?
Exactly. This study focused primarily on the properties of the yarn itself, which is fundamental. But the researchers point out that a crucial next step will be to actually weave or knit fabrics from these yarns and then analyze the characteristics of those fabrics.
How they feel, how they drape, how they perform in real-world use.
Precisely. Wear testing, wash testing, all of that.
So we've gone from something that seems simple stretchable yarn to some pretty advanced engineering with these rollers and feeding techniques. What's the main takeaway for our listeners from this deep dive?
I think the key message is that this modified W-groove roller shows significant promise for creating superior Siro dual core-spun yarns. It's a tangible improvement.
Better stretch, better strength.
Better stretch, greater strength, and improved overall quality compared to those made using traditional methods. And, importantly, the specific way the core materials are introduced, particularly separating the elastane using that W-groove like in R5, makes a real measurable difference in the final yarn characteristics.
So for you, the learner, you now have a deeper understanding of the kind of innovation that's happening, often unseen, at a fundamental level in the world of textiles. These seemingly small changes in how yarn is manufactured can have a direct impact on the comfort, the performance, and maybe even the lifespan of the clothes you wear every single day.
And maybe this raises an important question for you to consider. How many other seemingly established processes in textiles or anywhere else in the world around us are actually ripe for similar kinds of innovative disruption?
Yeah.
Where just a small change in the way things are done, like modifying a roller groove, can lead to significant improvements in the final product. We encourage you to think about the unseen engineering that goes into the everyday items you use.